Hey everyone, welcome back to Windows Seat Studies. So today we are going to continue learning histone acetylation. In last class we learned about histone acetylation, how it is an active mark and how it perturbs the chromatin environment. Today we will be learning about the enzymes which are concerned when the histone is acetylated. So histone acetylation is an active mark. So whenever histone is acetylated, it loses up the positive charge. Okay, it neutralizes the positive charge, and that is why DNA histone interactions are weakened up. So this is an reversible mark, so this reaction is reversible. So histone is acetylated with the helps of enzyme which are known as HATs, histone acetyl transferases. Okay, so ases symbolizes that it is an enzyme, while the prefix is it tells about us about the substrate, so it is going to work on the histone. Acetyl transferase transfer means it shows that it transfers the acetyl group on the substrate, which is histone. So this is how HATs, histone acetyl transferases, are the enzymes which are going to transfer the acetyl group on the histone, while the reverse is done by HDACs. Okay, HDACs are histone deacetylases, histone deacetylases. So they remove the acetyl group and convert histone, acetylated histone to the histone. Okay, so let's now take a look at the different classes of the HATs and HDACs. So let's first learn about histone acetyl transferases. So histone acetyl transferases have two types. There are two types of histone acetyl transferases, type A and type B. So they have different distinct mechanisms. Why? Because they transfer the acetyl group on different types of histone. So type A hats are nucleic hats. They are present in nucleus. So again, they are further divided into GNAT, MIST, and P300 or CBP. So GNAT has the example GCN5, PCAF. So these different examples, these are these are grouped in different category because they acetylate, they work on the different lysine residue. Here you can see GCN5 works on H3K9, while PCAF works on H3K14. The MIST has example TIP60 and MOS, where TIP60 works on H3K4 or K8 lysine residue, or MOS works on H3K14 or K23 residue. The P300 has examples CBP and P300. These are the two examples of type A hats. So CBP works on H2A K5 residue and H2B K12 residue, while P300 works on H3K14 and H4K5 or K12 residue, sorry, K8 residue. So these are the different types of the type A hats. So I don't expect you to remember all this. Just remember that type A is nucleic. Okay, let me write it with a pen. So this is nucleic hats. They are present in nucleus. Okay, while type B are the cytoplasmic hats. They are present in cytoplasm. Why are they present in cytoplasm? Because they acetylates the free histones, the newly synthesized histones, which are non-chromatin histones, means they are not assembled into nucleosomes. While the type A1, they work on the histones which are already assembled into the nucleosome. So they work on nucleosomal histones. Okay, while type B, they work on non-chromatin histone. That is why they why is it significant? Because the newly synthesized histone, they get acetylated, and that helps in nucleosomal or say chromatin assembly. Okay, that helps in chromatin assembly. So whenever histones are newly synthesized, they are acetylated in cytoplasm by type B hats, and that helps in deposition of histone, means the assembly of histone into nucleosomes, means the chromatin assembly. They help in the deposition of histones, and the H4K5 and H4K12 residues are acetylated in the cytoplasm. So only those residues are acetylated by type B hats, while type A hats are of those three different types. So what is the take home message? What is the main thing that you have to remember? That type A are the nucleic hats, and they work on the substrate is nucleosomal histone, while type B are cytoplasmic one, and they help in deposition of histones. So that is all about histone acetyltransferases. Now let's take a look at histone deacetylases. Okay, so there are different classes of histone acetylases. The four classes: class 1, 2, 3, and 4. These are the different classes. The class 1 is homologous to East RDP, while class 2 is homologous to East HDA1. The class 4 has HDAC 11. The class 1 has HDAC 1, 2, 3. Class 2 has HDAC 4, 5, 7, 9, as well as HDAC 6 and 10. So these classes are different. Why? Because they share different sequence homology. So the all of the class 1 HDACs like HDAC 1, 2, 3, they have some sequence homology, and that is why they have put in class 1. While class 2 has again further categorized into two different classes, the second A and second B. The second A and second B, those, they are differentiated, they are categorized due to different domain organization. Okay, the different domain organization and the sequence homology of the HDACs. Okay, and this is the criteria of categorization of those class 2. So they are categorized into class 2A and class 2B. Class 2A has HDAC 4, 5, 7, 9, while class 2B has HDAC 6, 10. The class 4 has HDAC 11. So why have I explained class 1, 2, and 4 and class 3 last? I'll tell you the reason later. So class 3, they are named after SIR2, and that is why they are known as sirtuins. They consist of sirtuins 1 to 7. So all the classes except class 3, means class 1, 2, and 4, they share some sequence homology as well as structural homology, which due to which they have different catalytic activity. So the class 3, class 1, class 2, and class 4, both of them have different catalytic activity. That is why the class 1 to 4, they do not require any cofactor, but they require zinc ions for their functioning, while class 3 means sirtuins, okay, they required NAD plus as a cofactor for the functioning. So so in the HDACs, I don't expect you to remember the all of the enzyme names. You can if you have a good memory, but the take home message is that class 3 is known as sirtuins, and it is a very different class because it requires NAD plus as an cofactor. So it has different catalytic activity from the other classes, while class 1, 2, 4, they do not require any cofactor, but they require zinc ions for their functioning. So this is all about the histone acetyltransferases as well as histone deacetylases. So we have completed histone acetylation here. In the next video lecture, we will learn about histone methylation. Till then, see you. Bye bye.